We're going to look at simplifying our rational exponents. So remember we have this rule that if you have a to the n over m, that's the same thing as the mth root of a to the n. Okay? So here, when we're looking at this, the denominator goes to what kind of index it is in the root. So if you just write like this, then the 2 becomes the index in there. Or you can think of that it just falls over and it falls into place as to where they're supposed to be. So this is 4, the square root of 4 to the first, right? So we don't need either of those numbers. So remember on the square root we drop the 2 and we don't have to write something to the first power. So then we can use our skills of simplifying rationals. So this is 4 is 2 times 2, so there's a pair, so then this simplifies to 2. Okay. If we look at the next one, again we've got that same thing where you can either think of I'm going to tip it to the side, or I've got this as the root. So this will be the cube root of 27. Well, 27, if we break that down, that's 9 and 3, and 9 is 3 and 3. Again, it's a cube root, meaning we need a group of 3. So in this case, we have 3 3's, so then that gives us 3. If we look at our next one, the denominator is what kind of index it is. The numerator is the power. So this will be the square root of 18 to the first. Well, 18 is 2 times 9. 9 is 3 times 3. So we have a group of 3's and then a loner 2. So this turns into 3 root 2. And our 3 came out because it was a pair. Okay. Now, this next one, we have to remember some information about our negative exponents. When you have a negative exponent, it's the same thing as 1 over the base with the power to the positive exponent. So this is the same thing as 1 over 64 to the 1/2 power. So now I'm going to look at the 1/2 power. So I'm going to take the square root of 64 to the first. Well, 64 is 8 times 8, so then this will simplify to 1/8 because the pair of 8's come out. Okay. We still have our rules that we can use for exponents, but we can now apply them to when we have rational exponents. So when you're multiplying two bases, you can add the exponents. When you're dividing two bases, you can subtract the exponents. When you have a power to a power, you can multiply. And then we also need to remember anything to the 0 power is 1. Our negative exponent moves it to the denominator and makes it positive, or if it's in the denominator and negative, you can move it to the top and make it positive. And then if you're taking a fraction to a power, it's the top to the power and the bottom to the power. And then if you have two things in parentheses being raised to a power, each thing gets raised to the power. Okay. So for example here, what I can do is we can utilize this to help us multiply radicals with different indexes. So we've done multiplying radicals with the same index, but now if we look at different indices, okay, we can multiply the two of them. Now on this, the radicands must be the same. So remember the radicand is the thing underneath the root. Okay. So here I can change this 7 to be the 7th to the 1/2 and the 7 to the 1/5, right? Because we had an unsaid 1 here and an unsaid 1 here, and the kind of root it was the 5th root. Oh, I wrote a 2 when I wanted a 5. Sorry. So now we have, and I need a multiply sign, 7 to the 1/2 times 7 to the 1/5. So we're multiplying with our bases, so that means we can add our exponents. So I can have 1/2 plus 1/5. So if we remember our fractions, we need common denominators. So the common denominator between 2 and 5 is 10. To go from 2 to 10, we have to multiply by 5, so I multiply the top by 5. To go from 5 to 10, I have to multiply by 2, so I multiply the top by 2. So 1 times 2 is 2. So then I can add, and we do top plus top over the common bottom. So 5 plus 2 is 7 over the 10. So then we can switch this back to a radical. So this will be the 10th root of 7 to the 7th. Notice this number is lower. I don't have anything that I can do to take out because I need groups of 10. So you could either have either of those answers and be okay. Now notice on this one, we have the bases are the same, or if we were to put them in the roots, the radicands would be the same. So we have the base times the base, so that means that we can add the exponents. So here we're going to do 2/3 plus 1/4. Again, if we remember about our denominators, between 3 and 4, our common denominator is 12. To go from 3 to 12, I have to multiply by 4. So I multiply the top by 4, so 2 times 4 gives us 8. To go from 4 to 12, I have to multiply by 3. So I'm going to multiply the top by 3. So 1 times 3 gives us 3. So we're going to do 8/12 plus 3/12, which gives us 11/12. Again, I could choose to switch this to the 12th root. Oops. The 12th root of x to the 11th. This number is smaller than this one, so there's not any that I can take out. So then this is one of those is my final answer. Now this one looks weird, right? Because it's a radical and a radical, which seems bizarre, but you can still do it. So here, if I take this inside one and I rewrite this inside one is really x to the 1/3 because we have a first power here. Well, if we look at what kind of root we have, that's the second root. This is a square root, and then this whole thing is really being raised to the first power, right? So I have that is being raised to the 1/2 power. Well, here we have a power to a power, so that means I have to multiply the exponents. So then this becomes 1/3 times 1/2. When we multiply fractions, we multiply straight across. So top times top over bottom times bottom. So this gives us x to the 1 times 1 is 1, 3 times 2 is 6. So we get x to the 1/6, or I could do the 6th root of x to the first power. So either of those would work for your answer. Okay. We can also have a mix of things. So we want to simplify the expression and we don't want any negative exponents. Okay. These are two bases. They have exponents, so that means that we can add them. So we have 1/3 plus 2/3, which gives us 3/3, but notice I can reduce 3/3. 3/3 is really 1, so this is just 4 to the first, which is just 4. Okay. If we look at the next one, we've got 3 to the first, it's an unsaid 1, times 3 to the 1/5, so we're going to add the exponents. So we have 1 plus 1/5. Well, remember that 1 really has a denominator of 1. So between 1 and 5, your common denominator is 5. To go from 1 to 5, we have to multiply the top by 5. So 1 times 5 is 5. To go from 5 to 5, we don't multiply by anything, or you can think you multiply by 1. So 1 times 1 is 1. And I'm going to add. So then this gives us 6/5. So now we have 3 to the 6/5. If we switch this to a root, this will be the 5th root of 3 to the 6th, which notice I have a group of 5 of these because I have 6 of them, right? So 5 of them can be taken out as 1. So one of the 3's comes out, and then we have a 3 left over. Or the other way that you could think of it is that this is 3 to the 6/5, which is really 1 and 1/5. Right? So if we do the 3 to the first, then that's just 3. And then we have times by 3 to the 1/5, which I can write as the 5th root of 3. Right? So all of those are fine answers that you can get, which we could also write as 3 times 3 to the 1/5. So if we look at the next one, we're multiplying with our bases, so we're going to add our exponents. So we have 1/2 plus 1/3. To get a common denominator between 2 and 3, our common denominator is 6. To go from 2 to 6, we need to multiply by 3. So 1 times 3 is 3. To go from 3 to 6, we need to multiply by 2, so I'm going to multiply the top by 2, so 1 times 2 is 2. So we get x to the 5/6. Or I could write this as the 6th root, remember, because this gives us our root, where you tip it over and the 6 goes here and then the 5 goes here. The 6th root of x to the 5th. I don't have 6 of them to come out, so I just leave it as that. Here we have a power to a power. When we have a power to a power, we're going to multiply. So we have x to the negative 1/3 times by 6. Remember, when we're multiplying fractions, remember, first of all, the 6 can be written as a fraction when you're dividing by 1, and then I'm going to multiply straight across. So I'm going to do negative 1 times 6 is negative 6, 3 times 1 is 3, so then that simplifies to negative 2, so we're going to have x to the negative 2. But remember, we don't want negative exponents, so when it's a negative exponent, you can switch it to the denominator and make it positive. So this is the same thing as 1 over x squared. Okay. Here, we have two things being divided. They're the same base, so I can subtract. So this is an unsaid 1, so we're going to do 5 to the first minus 2/3. So 1 minus 2/3. Well, 1 is really 3/3. So 3/3 minus 2/3 is 1/3, which I could rewrite this as the cube root of 5. 5 doesn't break down. I don't have anything that I can pull out because there's not a group of 3 of them. So I get the cube root of 5. Here we are dividing again. So to divide with exponents, you subtract the exponents and keep the bases the same. So we have y to the 2/3 minus 1/5. Well, we need a common denominator. The common denominator between 3 and 5 is 15. To go from 3 to 15, we multiply by 5. So 2 times 5 gives us 10. To go from 5 to 15, we have to multiply by 3, so we're going to multiply the top by 3. So then we do 1 times 3 is 3, and then don't forget we had a subtract sign between them. So we're doing 10/15 minus 3/15, which gives us 7/15. So we have y to the 7/15. Or this would be, the 15 is the kind of root, so the 15th root of y to the 7th. Notice I don't have any that I can take out because 7 is lower than 15. Okay. Here we get to a slightly more complex one. We have, first of all, a negative exponent, and we've got powers. Right? So when you have a power to a power, you're going to multiply. Or you could start by saying, well, these two are the same, so I need to add them. There's a whole bunch of different ways that you could go here. All of them get you to the same point. So I'm going to raise each one to the negative 2. So I'm going to take the cube to the negative 2 and the 2/3 to the negative 2. So I'm going to multiply each one of these. So I have 3 times negative 2 times x to the 2/3 times by negative 2. So the first one, 3 times negative 2 is negative 6. And then 2/3 times negative 2, remember negative 2 is really over 1, so we do top times top. So 2 times negative 2 is negative 4. And 3 times 1 is 3. So we get x to the negative 4/3. Well, we have two bases being multiplied, so I'm going to add their exponents. So now I can do x to the negative 6 plus negative 4/3, so I need a common denominator. 6 is really over 1, so our common denominator is 3. To go from 1 to 3, we have to multiply by 3. So I multiply the negative 6 by 3, which gives us negative 18. To go from 3 to 3, it keeps it the same, so we have the negative 4, or plus a negative 4, you could do subtract 4, any of those are fine. So we have x to the, when you add fractions, you're going to do top plus or minus the top over the common bottom. So negative 18 plus negative 4, which gives us negative 22/3. Again, there's still a couple of ways that you could go from here. You could switch this to a power, not a power, a root. Right, this would be the cube root of x to the 22. We would need to take care of the negative first. So I would do, this is 1 over x to the 22/3. So then I could say, well, this is 1 over the cube root of x to the 22nd, and then we can say, well, how many 3's go into 22? There's 7 of them and 1 left over. So then we would have an x to the 7th on the outside and an x to the 1st underneath. Or we could say, well, negative 22 thirds is really negative 7 1/3, right? So then this would be 1 over x to the 7 1/3. So then I can say, well, this is really x to the 7th and then the cube root of x, right, which gets us to the same spot that we had here. So there's a couple ways that you can get there, but that would be the final answer that we want. If we look here, we have a negative exponent, so we don't want a negative. So to make it so it's not negative, I need to move it to the top. So we're going to move this up here. So this will be 3 times z to the positive 2/5 since I moved it to the top now. Okay. Now the 2/5 is only being raised to the power with the z. The 3 doesn't have the 2/5. So when I go to switch this to a root, this will be 3 the 5th root of z squared. I can't simplify this anymore because the z squared, there's only 2 of them and I need 5 of them to get out. So that's how we would simplify that. So your rules still apply. All of these rules that we've done before still apply even though we have rational exponents now.